Hi, algebra classes. We are talking today about section 1.3. This is the only new section that you actually have within this chapter. So we're going to start with a warm-up. Would you rather have a stack of quarters from the floor to the top of your head, or would you rather have $225? I want you to pause the video. I want you to write down your thoughts, and once you have those, you can come back. Okay, now that you have that, I'm not here, we're not going to discuss with your table group, but I did want to show you this quick little video. Okay, so that just kind of gets the table started for what we're doing today. We're talking about measurements. We will come back to homework at the end, but I want to talk about the world's largest cup of coffee. And what information do you need to know to determine the new record, and how long do you think it's going to take to fill it? I want you to think about those as we look at this next option here. So think about that cup of coffee. And I'm going to tell you that the cup is 7 feet high and has a 7-foot diameter, which is 7 feet across. I'm also going to tell you that there are 7.48 gallons in 1 cubic foot. And I'm going to tell you that the cup is filling at a rate of 9 fluid ounces per second. And so you can see that that is going to help you. Knowing that information, you can actually figure out how much is in that cup of coffee. I want you to see if you can figure out actually how much coffee is in it. You can use a calculator on your computer if you need to use one. You're going to need to use one. So pause the video, see if you can figure it out just randomly by going through things. And then when you're done, come back and we will see.
Well, we're shooting for up for a noon kickoff.
Okay, so that just kind of gives us the idea of what we're working with today. In your notes, go ahead and write all of this stuff down. You're probably going to need to pause the video. You do need to know the vocabulary rate and equivalent rate, so make sure you write all that down. And then know that the measurements are going to be given to you, anything that you are going to need, so you do not have to memorize these. All right, so if I am working at how many liters are there in 30,000 milliliters? Okay, I'm going to start by drawing what I call a ladder. And so we're going to start with a line across and we're going to put straight down. What I do know is right now, how many liters are there in 30,000 milliliters? Well, I have 30,000 milliliters. And the question becomes, how many liters do I have? Well, that's what I don't know. In order to do these train tracks, what I need to know is I need to look back at my page and remember that there is 1 liter for every 1,000 milliliters. I want to be able to cancel. So just like fractions, I'm going to put 1,000 milliliters on the bottom and 1 liter on the top. The reason I do that is because my milliliters are going to cancel out just like a fraction when you cross reduce. Okay, these two right here are equivalent. Now all I need to do is I need to multiply straight across. Well, 1 times 30,000 is going to be 30,000. And I don't know what this is, times 1,000. And then I can divide, which actually I can just go like that. So I know that there are going to be 30 liters, because liter is the only label I have. Okay, so if I'm doing inches in a mile, I'm going to start that out with, again, my train tracks. And I don't know how many inches are in a mile, so I know that there are 12 inches in 1 foot right now. I also, again, if I look up to my chart, I know that there are 5,280 feet, so I'm going to put that on the top, 5,280 feet, in 1 mile. Okay, so now I have my feet that can cancel. I'm left with inches and miles. So if I take 5,280 times 12, that's going to give me 6,000. So remember, I multiplied straight across. 63,360 inches per mile. So that would be my answer. Okay. Now I have a conversion here. Let's start over. They're asking me to convert 60 miles an hour to how many feet per second? Okay, so I'm going to do my train track, and I'm going to say, okay, so I have 60 miles in 1 hour. That's what they give me. That's the given. I need to get it all the way to feet per second. Since I have 2 different labels, I actually need to work on 2 different things. I'm going to start with miles for no reason other than I just used miles before. So I know that 1 mile is 5,280 feet. Okay. Am I going just to feet? Yes, I am. So that means that my miles can cancel. I'm left with my label feet, so that part's done. Now I need to go to seconds. Okay, well, if I have hours, since this hour is on the bottom, I need to put the hour on the top. So 1 hour, a conversion for that, an equivalent fraction would be 60 minutes. Okay, now since hours here, it can cancel with this one. Remember, my numbers don't cancel. It's just the labels that I'm trying to get rid of. Okay, so I'm just getting rid of my labels. All right, so now I have minutes on the bottom, but I'm trying to get to seconds. So that means I had to put minutes on the top. Well, let's go 1 minute. I know it is 60 seconds. Okay, so if my minutes cancel, then I'm just left with 60 seconds. Now I have feet per second, which is what they asked me to look for. I'm going to multiply everything straight across. I know you don't have a calculator and you won't need one actually for this, but you can use the calculator on your computer for today if you need to. So I'm going to take 60 times 5,280. I'm going to get 316,800. And then I'm going to take 60 times 60, which is going to give me 3,600. Now that's a really big fraction. And what I want to find is a unit rate. So basically, I'm just going to divide the two. I'm going to take 316,800 divided by 3,600, and I'm going to end up, look at that, 88 even. That would be 88 feet per second is going to be my answer. So 60 miles an hour. So if you're driving down the interstate at 60 miles an hour, that's the same as going 88 feet every second. Okay? So same thing. We're going to start with my 300. And we're going to do gallons over 1 hour. And I need to convert that all the way to cups per minute. Again, it doesn't matter which I start with. I'm just going to start with gallons because it's on top. And then I need to look at my conversions. Okay, so I know that there are 4 quarts in 1 gallon. Oh, I also know that there is, let's see, in 1 quart. Dang, I did that backwards. Hold on. I need to make sure I have them opposite of each other. So in 1 quart, there are 2 pints. So remember, gallons are canceled. Quarts are now canceled. Pints are now canceled. And finally, in 1 pint, I have 2 cups. Okay, so I have worked all of my conversions out. I'm all the way down to cups. Okay, now I need to do hours and minutes. In 1 hour, since hours on the bottom, I need to do 1 hour on the top, and then I'm going to do 60 minutes on the bottom. Okay, so hours cancels. Now I'm down to minutes and cups, which is what I wanted to get originally. I'm going to multiply everything straight across. So I'm going to take 300 times 4 times 2 times 2 times 1, and I'm going to get 4,800. On the bottom, I'm just going to multiply straight across. So 1 times 1 times 1 times 1 times 60 is going to be 60. Now I need to divide the 2, and I'm going to end up with 80 cups per minute. So if I'm filling up a pool and it goes to 300 gallons an hour, that means I'm filling up with 80 cups per minute, which is a very large hose. Okay, moving on. This one is all about money. It says that Jill earns $125,683 in 2.4 years. What is her yearly salary? Well, really, all I need to do is divide these two. So I'm going to take 125,683 divided by 2.4. What you're going to see with this one is you're going to actually get a decimal. I'm going to have to round it off because it's money and I need to round, and so I have a fair change. Now, if she works 240 days in a year, what's her daily rate? Again, I just need to take this rate divided by 240. I'm ending up with approximately $218.20, roughly, give or take. From here, it says if she works 8.5 hours, what's her hourly rate? Well, again, we're going to divide by 8.5 on this one. So roughly she's working for $25 an hour. And then you can go back and I want you to try to figure out at this salary, how long is she going to have to work in order for her to actually get $1 million. Now we all can make $1 million in our lifetime. It's a matter if we save it or not. Okay. Next, you can produce 14 files per hour. If 30 files are equivalent to 90, how much money do you make in an 8-hour day? Okay, so I went ahead and did this one for you just so you can see it. So I did 14 files over 1 hour because that's what they gave us. And then we're going to go back, and I went ahead and just picked the hours because the hours are going to cancel. There are 8 hours in 1 day. That's what I want to end up with. And since the 14 files is currently on the top, I need to put my 30 files, because I have an equivalent rate right there, on the bottom so that those can cancel out. So in one day, how much money can you make? You multiply straight across, and then you divide. Pause the video and go back if you need more space. Okay, so next one. I want you to pause the video and try to do this one on your own, and then come back and see if you can figure it, if you did it correctly. Okay, so this one was kind of tough. What you need to do is compare the two packages. Package A is pretty basic, so I just went ahead and I just took package A and copied it down here. This is what my go-to was trying to get. Then I took package B, and I said, okay, if this is what they give me, I'm going to start it off here, and I need to make that work out all the way down to ounces per cent, okay? So I went that way, and I canceled out my pounds first, and I got to ounces. And then, so I had my ounces, and then I needed a cent. Well, I know that I had $13 and $1, so I know that there's 100 cents in a dollar. So if I multiply those out and I divide, I end up with this. So they're saying which package is cheaper. Well, technically, this is going to be, this one, it rounds up. But this one is actually, package B is going to be just a slight bit cheaper.